Martian surprise, NASA's Perseverance makes new discoveries in Mars' Jezero crater. The Mars rover found that Jezero crater's floor is made up of volcanic rocks that have interacted with water. NASA scientists got a big surprise when the Perseverance Mars rover began analyzing rocks on the floor of Jezero crater in the spring of 2021. They had expected to find sedimentary rock because the crater held a lake billions of years ago. This would have formed when sand and mud settled in a once watery environment. Instead, they discovered the floor was made of two types of igneous rock, one that formed from volcanic activity at the surface and the other originated from magma deep underground. The findings are described in 4 new scientific papers published today, August 25, 2022. In Science, one offers an overview of Perseverance's investigation of the crater floor before it arrived at Jezero's ancient river delta in April 2022. A second study in the same journal describes in detail the distinctive rocks that appear to have formed from a thick body of magma. The other 2 papers, published in Science Advances, document the unique ways that Perseverance's rock vaporizing laser and ground-penetrating radar established that rocks cover the crater floor. Rock of Ages igneous rocks make excellent timekeepers. This is because crystals inside them record details about the precise moment they formed. One great value of the igneous rocks we collected is that they will tell us about when the lake was present in Jezero. We know it was there more recently than the igneous crater floor rocks formed, said Ken Farley of Caltech, Perseverance's project scientist and the lead author of the first of the new science papers. This will address some major questions: when was Mars' climate conducive to lakes and rivers on the planet's surface, and when did it change to the very cold and dry conditions we see today? However, igneous rock isn't ideal for preserving the potential signs of ancient microscopic life Perseverance is searching for, because of how it forms. On the other hand, determining the age of sedimentary rock can be challenging, especially when it contains rock fragments that formed at different times before the rock sediment was deposited. However, sedimentary rock often forms in watery environments suitable for life and is better at preserving ancient signs of life. That's why the sediment-rich river delta Perseverance has been exploring since April 2022 is so tantalizing to scientists. The rover has begun drilling and collecting core samples of sedimentary rocks there so that the Mars sample return campaign could potentially return them to Earth, where they could be studied by powerful lab equipment too large to bring to Mars. Mysterious magma-formed rocks. A long-standing mystery on Mars is solved in a second paper published in Science. Mars orbiters spotted a rock formation filled with the mineral olivine years ago. Measuring roughly 27,000 square miles, 70,000 square kilometers, nearly the size of South Carolina, this formation extends from the inside edge of Jezero crater into the surrounding region. Scientists have offered various theories on why olivine is so plentiful over such a large area of the surface. These include meteorite impacts, volcanic eruptions, and sedimentary processes. Another theory is that the olivine formed deep underground from slowly cooling magma, molten rock, before being exposed over time by erosion. Yang Liu of NASA's Jet Propulsion Laboratory, JPL, in Southern California and her co-authors have determined that the last explanation is the most likely. Perseverance abraded the rock to reveal its composition. Scientists studying the exposed patch homed in on the olivine's large grain size, along with the rock's chemistry and texture. Using Perseverance's planetary instrument for X-ray lithochemistry, or PIXL, they determined the olivine grains in the area measure 1 to 3 millimeters, much larger than would be expected for olivine that formed in rapidly cooling lava at the planet's surface. This large crystal size and its uniform composition in a specific rock texture require a very slow cooling environment, Liu said. So, most likely, this magma in Jezero wasn't erupting on the surface. Unique science tools. The findings of science instruments that helped establish that igneous rocks cover the crater floor are detailed in the 2 Science Advances papers. The instruments include Perseverance's SuperCam laser and a ground-penetrating radar called RIMFAX, radar imager for Mars subsurface experiment. SuperCam is equipped with a rock vaporizing laser that can zap a target as small as a pencil tip from up to 20 feet, 7 meters, away. It analyzes the resulting vapor using a visible light spectrometer to determine a rock's chemical composition. During Perseverance's first 10 months on Mars, SuperCam zapped 1,450 points, helping scientists arrive at their conclusion about igneous rocks on the crater floor. In addition, SuperCam used near-infrared light, it's the first instrument on Mars with that capability, to find that water-altered minerals in the crater floor rocks. However, the alterations weren't pervasive throughout the crater floor, according to the combination of laser and infrared observations. SuperCam's data suggests that either these rock layers were isolated from Jezero's lake water or that the lake existed for a limited duration, said Roger Wines, SuperCam's principal investigator at Purdue University and Los Alamos National Laboratory. RIMFAX marks another first. Although Mars orbiters carry ground-penetrating radars, no spacecraft on the surface of Mars have before Perseverance. Being on the surface, RIMFAX can provide unparalleled detail, and surveyed the crater floor as deep as 50 feet, 15 meters. Its high-resolution radargrams show rock layers unexpectedly inclined up to 15 degrees underground. Understanding how these rock layers are ordered can help scientists build a timeline of Jezero crater's formation. As the first such instrument to operate on the surface of Mars, RIMFAX has demonstrated the potential value of a ground-penetrating radar as a tool for subsurface exploration, said Svein Erik Hamran, RIMFAX's principal investigator at the University of Oslo in Norway. The science team is thrilled by what they've found so far, but they're even more excited about the science that lies ahead.
Sick, feeling sicker than you know. Killed a bird without a stone. Talk to